So the stage is yours.
Thanks. Hello all. I'm Matthias. I kind of, started using Linux, and then probably like some people here in this room was wondering, hey, this is a nice tool. Why isn't this available as a package? And that's how I kind of got sucked into packaging. And as this was a Rust tool, I kind of then started contributing to the Rust team. And yeah, that's why I'm here today, to talk a bit about what we do in the Rust team, and then talk about a bit what I've been doing, packaging GTK and Rust, which I believe is pretty cool. A bit of an introduction to Rust. For those who don't know, you have, it's a programming language, obviously. It's still like new when you compare it to C. Like C has been around since, well, forever, I guess. You have Rust C, which is the compiler. Then you have Cargo, which is both the build system and the package manager. It's a bit like pip, if you know Python. And then you have crates, which are kind of like the libraries used to build things. This is actually common, like the standard library isn't that mighty, so to speak, and if you want to build something, you almost certainly have to use at least 5 crates probably. And they're distributed at a central registry, crates.io. And then we have debCargo. This is a Debian tool which does a lot of heavy lifting in the background. So it computes dependencies, does feature resolving, and so on. So it creates a Debianized source directory. It's also written in Rust, and you'll see a bit what I can do later on. So there's already a lot of applications written in Rust, so you might know some of the program names I put on the slides there. So you have like CLI tools like bat, exa, ripgrep. Then there's GUI programs, and there's even libraries, like even Python cryptography, which is a pretty common Python package, uses some Rust code under the hood. So it's already pretty much you can't really avoid it. You have also librsvg, which is doing all the SVG rendering, for instance, in GNOME. So if you're using GNOME, you're also using this library. And so how does the packaging workflow work? So the team maintains Rust C, Cargo, debCargo, and RustUp, which is, if you're actually developing Rust, you can use this to install the latest toolchain, both the stable and the nightly one. We have a big monorepo where all the crates live, and each crate has a own subfolder where the changelog and packaging files are. And we, of course, update those, package new ones. If a crate gets obsoleted, we file a package removal bug and so on. And of course, do big transitions because each crate depends on another crate, a specific version. And more than often, if you want to update one crate, you then have to update 10 crates or even 50. So that's sometimes a bit of a hassle. So that's what we do. Now, if you may be wondering, I found this nice Rust project. How do I even start? Like, how do I know how much work it's going to be? We got a nice tool for that called Cargo Deb Status. And this is what it looks like. So you just run this against a cloned repo, for instance, and it shows you in these nice colors which packages are already in Debian and which are missing. Like for this simple example, all the white, or here indicated by this red emoji packages are not in Debian, and you also see the outdated tag, so that's pretty cool. So that's just a way to estimate how much effort it will be to actually work on a project. So usually it's pretty straightforward. Like packaging crate, we kind of pretty much automated it. So it's 2 scripts usually. One calls debCargo in the background, which creates this Debian source directory, creates under build a folder where it resolves all that, and best case scenario, you just then need to go into the build folder and run sbuild or whatever you prefer, and that builds the crate. Sometimes you have to tweak, obviously copyright, but also patch out some features, tweak Debian rules, tweak the tests, because it's not straightforward to run them. But most of the times it's you can easily package like 5 crates in a day if you want to do that. And I was mentioning features earlier. So this is like gated code, so to say. And in Rust, this is fairly common. And we resolved this early on by providing these features as virtual packages. As you can see here, for this example, this is then just the provides with those feature flags on top. And this was it's still one binary package with provides here. So and then if you for instance want to build something that needs the web PKI feature, it then gets provided, because it's still the same source code, but it wouldn't make sense to ship 10 binary packages for each feature. So that we resolved it that way. Now I'm gonna talk a bit about GTK-rs. Those are just Rust bindings to the C GTK libraries, and there's usually one low-level crate and a high-level crate. The low-level one usually makes unsafe calls, so that means direct calls to memory, for instance. And now pretty much all applications that are GUI applications in Rust use GTK4, and also most of them libadwaita. And the problem here is we need to then, if we want to package an application, this is also true for a package that is not on crates.io, and you want to have this as a binary package. You then need to translate the dependencies in cargo.toml into Debian ones. And we are also working on automating that. And you only need, so to say, the Debian control and rules file need to be a bit different, but the rest is standard Debian packaging. And I brought this example. You can see here, this is the cargo.toml file. You can see those dependencies. And here are certain features that this package depends on. And if we translate this into a Debian control file, this is what it looks like. So you can see here it build depends on those librust packages with those features enabled. And since those are provided by the virtual packages I mentioned earlier, those get pulled in and it works. And this is what the Debian rules file looks like for such a package. It looks a bit much, but it's kind of what we have to do at the moment. So here at the top, we just set some flags, really, and then use here also a specific wrapper script living in user share cargo bin. And then here, this step links all the crates living in user share cargo registry to our cargo home, which is Debian/cargo home. And yeah, this is it. And then debhelper just calls the build system and builds it. And it's fully offline, no internet access, all from trusted Debian packages. So yeah, this is a great thing. And yeah, why are we doing this? Well, obviously, because we want to use those packages. And obviously we support a lot of architectures, and we don't have to use Flatpaks. The size optimized. So, for instance, if you are on ARM, then you can execute this as native code, and the build is also reproducible, which is, I believe Holger will talk a bit about that. And yeah, we're contributing to the wider ecosystem because, for instance, the GTK packages, they are also adaptive. That means if you are using a phone with Linux Mobile, they will also just run as fine on there. So that's great. And there's a bit of an overview I made of currently GTK Rust packages in Debian. For instance, here is a pretty cool app called Railway, which allows you to look up travel information. And those two here at the bottom are supposed to be the default core apps in GNOME 46. So the camera app and the image viewer are already are supposed to be written in Rust and replacing the old ones. And that's what it looks like. So just a regular application. And the cool part about the image viewer is that it uses image loaders in the background to kind of offload the rendering. So the image viewer itself just then displays the result. Then I'm going to talk a bit about another cool thing, which is a work in progress, which is video offloading. So video rendering, as you might know, usually is done by OpenGL, so that happens on a CPU. This is pretty, rendering intensive. And with recent developments, it will be possible to offload the video to a subsurface, then let it be rendered there by the hardware, and then be played back. And so it works via dmabuf and GTK, and this will allow basically that you can watch a video and have pretty much no CPU load at all, because it's all going to be offloaded to the hardware, to the video hardware, where it's going to be decoded. And this is still a work in progress, but I believe this is a pretty cool thing to have. And it works by this GStreamer plugin, which is written in Rust and then gets built into an SO file that then other programs can use. So that is pretty much the end of my talk. So we talked a bit about the Rust ecosystem, the Debian Rust tooling, and what we do here. Questions?
Thanks a lot, Matthias. And there are questions.
What is the motivation to keep all code in a single repository?
Yeah, that's a good question. In the beginning, we decided it that way. It's just matter of effort, because we I think at the moment it's like 2,000 source packages or crates package as source packages, and if you had to do a single repo for each crate, this would be a huge effort, I guess. And also, if you want to, you often have to, like I mentioned earlier, update like 10 crates in a row. And if you're in the same repository, you can just do commit after commit, then like upload them subsequently, and then do it. It's not ideal, granted, but it has certain advantages.
This laptop runs Bookworm, but I need Mesa from testing. Mesa requires Rust. I can't backport Mesa with Rust, can I?
This depends which version of the compiler you need. So this is actually a problem, because backporting Rust C is a bit of an effort, but some team members have kind of started discussing it. And it's also backporting crates. We haven't really done that. We don't really have a policy for that. I kind of wanted to discuss that, because I mean it's possible, but it's also, you need to backport every crate with the specific version. It all needs to match, so it's a bit more involved, I guess. But we can discuss a bit about that later if you want.
I would love that, because you listed this as an advantage that now Rust is everywhere.
Yeah.
And for what I do, it's a disadvantage, because when I want to backport something, I then look at the dependency tree and I get 60 Rust crates that I have to backport just to get a small little feature from the library I actually need.
Yeah.
And that is hard right now.
Yeah, no, that's definitely a downside. But we can talk about that later.
Just one comment related to this.
Hi, just one question. So, as we said, there might be situations where there are lots of dependencies of other dependencies, some of which involve different versions for even the same crate to compile one project, right?
Yeah.
Are all of these, once they're packaged, uploaded as regular packages? So could it be that then in the new queue, 50 new packages will hit, and people will have to process them, and you have to wait for those to get processed? Or is there some kind of arrangement with FTP masters that they get treated differently? I'm just wondering how it works in practice.
No. So if, for instance, if crate A depends on another crate B, and then you have a crate C which also depends on B, but at a different version, what we pretty much always do is patch that, so the versions match. Sometimes they're breaking changes, so you have to maybe, then it gets a bit more involved. And what we do have is semantic versions. So when there's a huge ABI bump, we have technically two versions of the same crate. So version 1, for instance, and version 2. So crates depending on version 1 or version 2 can get both. So this is what we do. And if it's just minor differences from, for instance, from 0.13 to 0.14, which is usually patched, and 80% of the time it just works. So we obviously want to minimize the amount of packages we actually do upload.
Yeah, just one follow-up comment for the backports situation. The security team usually backports a more recent version of the Rusty compiler and toolchain to stable versions for support for compiling newer browser versions. Firefox and Chromium depend on Rust these days. and depend on fairly new versions of Rust. So you might be able to use these packages for backports of other stuff as well.
A follow-up question to the multiple versions being packaged. As far as I understand, when using non-Debian Rust crates, you can actually use multiple versions of the same crate in an application. But when you try that on Debian, you're faced with breaks and replaces. Can you briefly explain why we have to make them non-co-installable?
Yeah, I think I know what you mean. This is, like I said, usually you can just patch it upwards, but if you have, for instance, version 1, and then you need version 2, but also want to keep version 1, you need to provide both at the same time. So crates needing both versions can still compile.
But they are conflicting on the package level.
Not all the time.
Not all the time.
Yeah. No, those are different files, and they get installed in a different path. And this isn't really breaks and replaces, because you can kind of like it's one version, and then it's like technically a totally different version. So you don't need breaks and replaces. So that is because it's a Semver bump. So.
The question is, why do we have these breaks and replaces anyway? So practically they're there.
Helmut, I think the answer is that for very specific crates that are needed for a lot of packages, then the Rust team can decide to make two versions co-installable.
Yeah.
But the default process is not to do that, because it's a security support nightmare.
Yeah, thanks.
Just to relate to that, in the README of the Rust Cargo repository, there's actually a note now that multiple versions of a package are discouraged. So we shouldn't do that. And another question I want to relay from Elbrus from IRC. He's asking, as most Rust packages are sourced, why not drive for archive-wide changes such that you can build depends on the source package instead of needing binary packages?
Well, that is a good question. That is, like I mentioned earlier in my slides, that is because of the specific features those other packages or crates expect. So we kind of, unfortunately, need to go the route via binary packages which provide those features. I mean, I guess it probably could work that you just use the source package, but that way, like, it's even, for instance, if a crate would drop a feature between versions, and like I showed earlier, if you directly depend on the feature that your package needs, then if that feature then isn't present anymore, you directly will get a build failure and notice, hey, this feature disappeared. I need that to build my software. So that is also argument why we do it that way.
Unfortunately, we're out of time, but you can also always continue to talk about the Rust packaging afterwards. We'll be back in 5 minutes with Martin on XMPP and environmental measurements. See you soon, and thanks again, Matthias.